Hello mathematicians! Today we're going to be learning about slope-intercept form, and more specifically we're going to be covering negative slope. So if you recall back to our burning candle example, our candle started off with 13 centimeters, and as time went by, the candle melted and the height of the candle started decreasing, and then it continued decreasing until it was no more. So looking at this table, we could see that at 0 minutes, the candle was 13 centimeters because that's when the candle was lit. That's the height that it started off before the candle started burning. And then after 25 minutes, the candle was at 11 centimeters. After 75 minutes, the candle was at 7 centimeters. And after 125 minutes, the candle was at 3 centimeters. So here, after 25 minutes, our candle decreased 2 centimeters. Then after 50 minutes, our candle decreased 4 centimeters. After another 50 minutes, our candle decreased another 4 centimeters. Now, just by looking at our table, it seems that our candle is not decreasing at the same rate. So, let me just write our rate down. So our first change is that our candle melts 2 centimeters in 25 minutes. And then our second change is that our candle melts 4 centimeters in 50 minutes. So if we look at these two rates, we could actually see that they're equivalent because negative 2 centimeters in 25 minutes, if this happened twice, it would be negative 4 centimeters over 50 minutes. So these two ratios are equivalent, and we could also see that negative 2 times 2 is negative 4, and 25 times 2 is 50, making these two rates equivalent. So just be careful because sometimes it appears that our table is changing at different rates when it's not, and sometimes it actually is. So just be mindful of that. So here we have a graph based on our candle burning. So if we look at 0 minutes, our graph starts off on 13 because this is the initial value. So initially the candle is 13 centimeters, and this is also called our y-intercept. So this is 0, 13, which is our y-intercept. And it basically just means that when we light the candle, the height is initially 13 centimeters, okay? And that's all that means. And then as the graph goes on, we could tell that there are some exact points. Now I'm going to go through the graph. This is not an exact point. This one almost looks like an exact point, but it is not. This one is not. This one is not, and then here we have our first exact point, which is also on our table. And then as we keep going, here's another one, and here's another one. And you'll notice that if we have a linear function such as this one, that our points will be evenly spaced out, and if you see that they're not, you might be missing one, which is okay, as long as you have your line. Okay, so I'm going to just plot these for right now, and I'm going to show you guys how to get the slope based on our line. And I'm just going to pick any two random points, such as these two over here, and I'm going to draw a triangle to help us out, because remember, slope is rise over run. And so here we have two spaces, and since our y-axis is counting up by ones, each box represents one, so this is 2. And now, since our line is going down, I'm actually going to write -2, since from here to here it goes down, and then we go over, so rise over run. In this case, our rise just so happens to be negative. And here we notice that our x-axis is counting up by 5, meaning that each space here is actually representing 5 minutes. So from here to here, it's 5 minutes. From this space to this space, it's another 5. So 10, 15, 20, 25. So 25. So our slope is that our candle burns, so slope is that our candle burns 2 centimeters every 25 minutes. And we saw that before when we were looking at our table. Now I'm going to pick another 2 random points and see if we get the same thing. So I'm going to actually pick 2 points that are further away from each other. Such as these. And remember that our y-axis is counting by ones, so I could go 1, 2, 3, 4, 5, 6. And since it's decreasing, it's -6. And then here, remember that our x-axis, each space counts as 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. Okay, and if we do write out -6 over 75, we could see that we could actually simplify that. So if we divide by 3, we get -2 over 25, which is what we got before. So just be mindful that always try to simplify your slope if you can. Now, on that note, I know that it may be tempting to say that our candle decreases 1 centimeter every 12.5 minutes. However, because that's a decimal and here we have a fraction, it's not convenient to write it out that way. But that's most definitely true. And so with this being said, we have our slope and we have our y-intercept, and with that we could write an equation. Oops, sorry. So our equation starts as y equals, and y represents our y values, which is our centimeters, and the rate that our candle is decreasing by is 2 centimeters every 25 minutes. And we initially start off with 13 centimeters. And just a quick reminder, remember that y-intercept is where the line crosses the y-axis, and slope is your rise over run, in other words, your rate of change. Now, I almost forgot. Before we move on from here, we have our y-intercept because that's where our line crosses the y-axis. But if you look at our graph, our line also crosses the x-axis. And when it crosses the y-axis over here, it's called our y-intercept. Because it intercepts the y-axis. So down here, when it crosses the x-axis, it's called our x-intercept. Okay, and So our y-intercept in this case represents how tall our candle was when we first lit it. And down here, as time goes on, the candle gets smaller and smaller and smaller until it no longer is there. And our x-intercept represents when our candle completely melts. So how long it takes for a candle to be 0 centimeters. Now, if you look at the line, we know that it's somewhere between 160 and 165, but we can't really tell where it's at. So I'm going to rewrite our equation so we can look at it. Now, we might not know what our x is, our number of minutes, but we know it's when our candle completely melts. And that's when our y is 0. So for y is 0, we could solve for x. And the first thing that we would do is we would subtract by 13 on both sides. So then this cancels out. I'm left with negative 13 is equal to negative 2 over 25 x. And then in order to isolate our x value, we'd have to multiply by the reciprocal. So I'm going to rewrite this a little bit higher. So I'm going to rewrite negative 13 equals negative 2 over 25x. And so you could either multiply by the reciprocal, or first you can multiply by 25 on both sides, which might be easier. So 25 times negative 13 is negative 325 is equal to negative 2x. Divide both sides by 2. And x is equal to, negative 2. And x is equal to 162.5 minutes because we're talking about x. So it takes 162 minutes and a half for the candle to completely burn. So an airplane is 14,000 feet above the ground and begins descending at a rate of 2,000 feet per minute. So if we look at our graph here, instead of me writing 1,000, 2,000, 3,000, and so on, I wrote 1 through 15, and here I wrote feet in parentheses thousands, so that the person who's looking at this graph, or for yourself really, could look at it and see this is 1,000, 2,000, 3,000, and so on, instead of having to write all the zeros. So if our airplane is at 14,000 feet, that's our y-intercept, so that's the first point that I'm going to plot. And it begins descending at a rate of 2,000 feet per minute. So we go down 2,000 feet in 1 minute, down 2,000 feet in 1 minute, down 2,000 feet in 1 minute, and so on. And you'll start to see a pattern here. And after you've done that, you could just draw your line through your points. I'm going to try my best to make it straight. Okay, so a couple of things that we could have also done is we could have made a table. Minutes, which is our x, and feet, which is our y. And at 0 minutes, it's at 14,000 feet. At 1 minute, well, after 1 minute, it's at 12,000 feet. And then so on. So if we look at our table, once we get to 7 minutes, we get 0 feet, which means that the airplane has landed. And looking at our graph, we could also see that the x-intercept is at 7, 0, which means that 7 minutes the airplane will be at 0 feet above the ground. And our y-intercept is 0, 14, meaning that at 0 minutes, the airplane is 14,000 feet above the ground. So in this problem, our y-intercept is where the airplane currently is, and our x-intercept is where it lands. And finally, we could write our equation, y equals negative 2,000, because it's decreasing, x plus 14,000. And again, if we substituted y with 0, we'd get how many minutes it took the plane to land. So here we have a fish tank that is 20 gallons and is leaking 4 gallons every 15 minutes. So this time I'm going to start off with a table. So minutes, and gallons, and at 0 minutes, it's at 20 gallons. After 15 minutes, it decreases because it's leaking, so it's at 16 gallons. After half an hour, it's at 12 gallons. After 45 minutes, it's at 8 gallons. After 60 minutes, so after an hour, it's at 4 gallons. And then after an hour and 15 minutes, so 75 minutes, it's at 0, meaning the tank would have no water in it. And our graph, we could plot that. So 0, 20. So this is our y-intercept. Meaning how much water was in the gallon before it started leaking. And then 15, 16. After 15 minutes, it's at 16. And so on. So I'm just going to plot the rest. And again, you'll see that pattern that I was talking about again. And here we have 75, 0, which is our x-intercept. And in this case, it's when our water has completely leaked out of our gallon. So I'm going to try my best to make that straight. And that's it. So our equation in this case would be y equals negative 4x, because it's decreasing 4 gallons every minute, and then plus 20 because 20 is our y-intercept, which is our initial value.